Okay, I think we can start. We will switch to game industry now. Uh, Juho Syrjänen, from platform engineer from
Metacore.
Metacore
Yes.
Games, will start his speech now. So big applause for him.
Thank you. Sorry for my toolbar. I'm a Linux user with a MacBook. It's never like I don't know how these things work. But let's start by imagining the worst possible thing you can run on Kubernetes, a workload that hates being restarted. It demands downtime for minor changes. It's tightly coupled with a third-party vendor, and it clings to its internal state like its life depends on it. Now, when I think about a workload like this, I think about game servers. If you ever stared at your workloads and thought like, why does it feel like I'm babysitting virtual machines again on Kubernetes? This talk might be for you. So who am I? My name is Juho Syrjänen. I work as a platform engineer at Metacore Games, where we build, well, where we build games, but where I build platforms for running games. Metacore, we're Helsinki-based in Finland. We have about 80 million downloads on our main game, Merge Mansion, and quite a bit of users daily. I myself have been working with Kubernetes for quite some time. My background is in data centers and virtualization and things like this, but I've been doing a lot of consultancy lately as well. But for the past 2 years, I've been working in games. Now, let's get on with the talk. Why do game servers then hate running on Kubernetes? My spoiler for you is that they don't inherently hate Kubernetes. They just are the way they are. But there are a few different reasons. GG, okay, we're back. Yep, so they're very stateful. Traditionally, game servers have been notoriously not happy with restarts. And this really happens with always online games and games that deal with persistent player states. The history behind this is mostly that it's rather easy to get a game server up and running when you store these things into memory, and it's also quite performative and cheaper. But the root cause is that you do need to keep something always available and track the player, what it does in the game, and it often ends up in the server's memory. There are high tick rates. The client, the game, communicates with our backend dozens of times per second. If you do PvP, Counter-Strike, for example, 20 plus times a second, and offloading every single action that a player does to a database becomes very costly. Player model, that the data which is stored from the player, if you put that to a database every 15 times every second, for example, it starts to get quite costly, and it becomes a performance bottleneck. In my talk, I'm focusing on this sort of legacy side of the game servers, so always online, persistent state, and these things that have not traditionally been designed to be run on Kubernetes. And not all game servers are stateful. If you are in games and you don't have a stateful game server, I'm very envious of you. You're in a good place. But when they are stateful, it's rather painful to run. One game-specific thing, I guess, is that we are tied to these distributors. So in mobile games, we have Apple and Google. If you do console games, you have Sony and Microsoft, Nintendo. But regardless, you have to distribute your client somehow to the client devices. In our case, mobile games, so hundreds of different kinds of mobile devices, and every single build that you submit needs to also be approved. So this becomes a bit of a bottleneck for us. Apple especially doesn't like people's builds, and they tend to reject them. And then this DevOps loopy loop that we have all been using and being very happy with for the past X amount of years becomes inherently broken. So even if our backend could move fast, our client really can't. And this is the reality we will live with. We do have these things in games, especially in mobile games, called live operations, live ops, where we can actually change the game a little bit on the fly with configuration changes. So we can, for example, publish an event without having to publish a client build. But this only helps a little bit. Imagine there's a bug in a button in your game, and you need to resolve it fast. You need to wait for the approval, so it sucks. Some great ways to do. Google is pretty good with this. They're quite fast. Apple, well, let's not talk about Apple. Games industry is incredibly competitive. So if you lose your players, your game goes down. They just click again, they're playing your competitor's game. And they may not come back. And mobile games can become successful overnight. Imagine your game is new, you have your backend server set up, and you become featured in the App Store, for example, in the front page. Suddenly you have 200 times the players, and your backend can't scale. What do? You cry. Also, there's a lot of legacy involved. Game server SDKs usually use a lot of these non-distributed state handling tools, and the engines, of course, are also not designed to run in this cloud-native space, so modernization is a bit hard. And when you have a live game with thousands of different players, it's quite hard to re-architect that as well. So we're caught in this cycle where success drives player demand, and that drives feature pressure, and then that piles on deck debt. And we, at the platform team, we're stuck with this mess. The train keeps on going, and we're just riding it. This clicker is not the best. But good news, everyone. There are some solutions, at least, and there have been solutions for quite some time. Back in 2012 already, these guys from ArenaNet, the guys behind the Guild Wars franchise, they were doing seamless upgrades for the game, restarting their backend, and distributed sharding already in 2012. That was very good. MMOs, so Guild Wars is a massive multiplayer online game. It's kind of has the same issue as do mobile games. They are always online. They do handle a lot of player state, and they also do like this multiplayer sessions. So ArenaNet was already solving these issues with the seamless upgrade, the sharding, the high availability way before Kubernetes was mainstream. These two talks from GDC, the Game Developer Conference, are really good if you want to hear how things were done in the past before Kubernetes times. 2012 at least, 17 already there, kind of. They were doing it with on-prem servers, of course, and Windows, VMs, and Docker. But they did already have a microservice architecture for all of their critical functions, and they could do really cool stuff. Highly recommend these talks. Now we have a monolith. That's not great. So we can't update a single component. If one game server goes down, all the players on it lose their progress. That's not great. So the failures are high impact. Updates require extreme caution. We do need to bring the game down for things like this. And you might think like, what the hell? Come on. 2025, and you are doing this. I will tell you a little industry insight. If you go and see the top games that are being played on mobile today, at least half of them are still doing this as well. Yes, and I'm not lying. It really is so. For some reason, even though we have these cool things in the infrastructure side, so Kubernetes, all the hyperscalers, all the serverless stuff, all this great technology in the infrastructure space, the game servers, they always tend to end up in this sticky, stateful, bundled mess. Don't know how it happens. I guess, you know, it is what it is. There is some hope, though. So we, oh no, I went too far. There is some hope. This is not just a niche problem. The industry at large is sort of trying to solve it. We have cool things from Google, like Agonis, for example. It extends Kubernetes with CRDs to make game servers run better on Kubernetes. There's Microsoft Orleans. It's a .NET framework. It does this approach a bit differently, so it abstracts away the state handling by using virtual actors. And even these big guys, the AWS and the cloud vendors, they're acknowledging this space. But unfortunately, we are a platform team. We can't swap out the engine or rewrite the SDK. It's in the developer's hands. These problems are quite real and they frustrate me a lot. I can't do the things I would like to do. But what we can do is try to make this environment a bit less painful to run. It's not our job to write a SDK that can handle these things, but it is kind of our job to build the guardrails and abstractions around the game to reduce the pain. My synopsis is this. We want to do cool things, want to build a modern platform, but our workload hates what we're doing, and we can't make it like it. So why do we bother? Yeah, back in the days, in the virtualization field, we used to have these cool things called ESXi hosts, where we ran our VMs, and what we could do is we could do a live failover to a new ESXi host without memory loss, so we could have the whole thing running and only like maybe a few ticks of a ping were lost. So why not use just the VMs? Well, my answer is to this, even though it could be done, that it's not just the game servers that we run. I did get a little censored here, so this is a simplified map of our ecosystem. And I'm sorry if it's a bit small. So the game servers are just one box there, inside the blue box. And surrounding them, we have our observability stack, our CI/CD stuff, network stuff, developer tooling, analytics pipeline, LiveOps tooling. And if we go and design our platform only around the game servers, it's not good. It's a GG moment again. So I'm glad someone understands my references here. So running games on Kubernetes is inherently a bad idea, but Kubernetes does make it easy to maintain a lot of software under one layer abstraction. And that's why for a platform team like ours, it makes sense to consolidate things. We can't stretch ourselves too thin, so it is a choice between, yes, let's run a bunch of VMs and have okay time doing that, or then let's make a platform and run everything on it. Even if the game servers are sort of an awkward tenant on our platform, it kinda is still worth it, because the whole of the organization benefits of doing this. So we aim to build a modern platform that works in a broad scope, and then we adapt to make it host the games a bit more nicely. Well, let's say in their own terms. The rest of our stack, all the APIs, the LiveOps tooling, the telemetry, the observability stuff, that all loves Kubernetes. If we can find a way to isolate the troublemakers on this platform, then I think everyone would benefit. So the question is, our mess versus this lovely stuff here, how? And we can look at ArenaNet and think, okay, they nailed their stuff. Distributed sharding and seamless upgrades years ago, and we're still doing this? Well, for us, rewriting the SDK and splitting the monolith into microservices, it's just not realistic, unfortunately. Maybe someday, not now. So I ask instead how to suffer less with this. We can't eliminate the pain, but we can eat the painkillers and try to tolerate it. So I'll go through some steps next, what we have been doing to make it a bit better. Some of them might be, of course, obvious things, but I hope you get something out of it. So the first thing is, of course, to find knowing our enemies. Not everything in the cluster, a change in the cluster, can take down a game server or disrupt it, but some things definitely can. Think kubelet upgrade could possibly rotate your pod. Bad thing, we'll lose players. CNI reloads, configuration reloads, you miss a tick. Bad thing, you have corrupted player state. So disruption points are kind of all over there, over the place. So we need to make sure we build something around them to make sure that they don't affect our game. So the goal is rather simple. We try to isolate the troublemakers. And the troublemaker is the game server, not the rest of the Kubernetes native workloads. We let the rest of the platform move fast, but the game servers, we move deliberately. We built sort of a bubble around them, right? I think the first logical thing is to put them on a dedicated node. So what we've done, we have created a lot of these node pools in Carpenter, with some Argo CD stuff on the screen now. That way, the game server, it's isolated from the rest of the cluster. We enforce this with taints and tolerations. We have the highest priority classes and all this kind of normal stuff. But we try to avoid any sort of preempted stuff in the cluster. Of course, they have a lot of PDBs, the pod disruption budgets. So we try to aim, well, we are forcing 0 voluntary evictions. And we spread the workloads across zones and nodes, of course, to limit any blast radius when AWS decides to pull a plug on one of our nodes. This kind of setup plays also quite nicely with some cost-saving plans and while keeping the stability, but that's not really that interesting in the end. But the actual thing that is a bit of a problem when you run games is the networking. Games demand very tight latency and the network drops are bad. So game servers are a special client on a cluster. They live on the very edge, constantly talking to the world. That makes them kind of fragile and exposed, of course. And our game, the game backend, has ports open globally all around the world. People are connecting to the game all the time. So we try to avoid any sort of ingress controllers and gateway API controllers and things like this, which during reloads, configuration reloads, you have the routing table there, update, things like this, can cause disruption to the connectivity. So instead, we have a very dumb TCP load balancer on front of the game, and the clients connect to it directly. It's very boring, but it's very stable and predictable. Then we, of course, we use Cilium for its high performance, network performance at scale. And one good thing with Cilium is this wide support of network policies. Of course, Kubernetes has network policies natively, but Cilium also gives us a bit more flexibility around that. So we define these strict guard paths between the games and the supporting services, so there will be no accidental crosstalk, and this is really isolating the game from the rest of the cluster. We already have the nodes. The network itself, it is, yes, subnet. This is a shared thing. But the thing with the subnet is that we really benefit from the games and the supporting services living in the same area in the subnet. For games, shaving off the few milliseconds is very important. And when we also route within the same availability zone in the public cloud, we save a lot of money, like a lot. AWS says that it's 0.01 cents egress and ingress if you go cross-zone. And when we are moving data, we're moving, yes, very small bits, player models, but moving them a lot. So those costs really rack up. But sometimes we do need to update the platform and disrupt the game. There's no way we can rotate a node and have the pod not restart. It will go down. So this is one of the hardest things when you balance this speed with safety, but we use a lot of Argo CD to manage this. So every platform component, so think about the cluster add-ons like our storage providers and the Cilium, which does the CNI stuff, is part of our Argo stuff. And we do release continuously, often multiple times a day. But the game server clusters, they sort of follow a different path. When we have a breaking release coming up, which essentially we have mapped that, okay, it's going to disrupt the game. What Argo allows us to do is specify the sync window, which we can then tie to the planned maintenance of the game. That way we never push the breaking change to a live game. So we decouple these releases. Platform still moves fast. We can push out our stuff, upgrades, fixes continuously, but the breaking releases hit the game server clusters only when the game is already otherwise down. There's been a lot of observability talk in this KCD, which is great. We also have our own observability platform. It's based on the Grafana stack, so we have Logi, Mimir, Tempo for traces and all the rest. And also OpenTelemetry collector pushing everything here. So every cluster, every workload, including the game themselves, comes with the monitoring by default. And for games especially, I guess, observability is a bit more interesting here, because we don't really have too much visibility on the client side, but we want to trace all the player actions within the cluster and the game. So we can see, for example, if there's a drop in the tick rates, the latency, player session drops, things like this. These are signals that something is wrong, and we can then react. Basic metrics really are not cutting it. And lastly, we have a lot of policies, backbone of this predictable isolation. They let us sleep at nights, I guess, along with the observability. So we have a lot of RBAC, a whole ass repo for that. Every team and every service is sort of accessing what it needs, only that. And we do a lot of admission controller stuff with Kyverno, lots of policies, and also mutating webhook configuration, so we can actually autocorrect any bad things that go to the cluster. So they're kind of not just saying no, these policies. They're about building these safe defaults, so if teams try to break something, we try to at least not let them do so. So this sort of isolation, it gives us a lot of stability and autonomy as a platform team, and we can still do our cool things. While the game server benefits from the Kubernetes services, and we have the supporting service right next to the game server, so they can still act as if they were the traditional servers with minimal disruptions, even though they are pods in Kubernetes. So we can't force the developers to redesign the SDK or swap out the logic how they deal with player state. But what we can do, and this is like my hypothesis, there's no facts backing this up, but what we can do is to make the platform so easy to use that developers sort of naturally want to use it. And over time, I'm hoping that as they use our IDP, our platform, these things become cultural, and the developers rely more on the platform, and they will then have more incentive to design the future systems in a way that fit these cloud-native tools. This means like self-service environments. We have now a new cool feature on our platform where we can actually build up a whole game from scratch from your PR when you're making a change. Quick feedback loops through that, always having the telemetry there. It makes the platform nice to develop on. Hard words, this English. So, okay, this is what we do as a platform team, but if we can't make the developers change their mind, I'm hoping this is the last resort. The business will do it for us. So there are some benefits of running games on Kubernetes, for sure. Also a lot of disadvantages around that as well. But once we have been now migrating all of our games on our platform, and we're running everything on Kubernetes at Metacore, we've been able to reduce the infrastructure-related downtime by a lot. Previously, during a game release, when we were pushing out let's say a node rotation, could take us hours because AWS is very slow with the nodes sometimes. Last release, we did it in 5 minutes. We've been significantly lowering our network costs by routing zonally and inside the clusters. And with the right sizing tools, we also have cut down the basic cost of running the game a lot. These better insights via our observability platform also give us business insights, so the analysts like it. And our developer NPS is very high. So we used to be, before we run on Kubernetes, minus something, very low. Now we're in the positive, so it's good increase. So even though today we're kind of stuck with supporting these monoliths, I think there's some light at the end of the tunnel. There is some sort of a trend you can see that the infrastructure and platform work is starting to be considered more in game development. And I'm basing this claim on the amount of GDC talks, the Game Developer Conference talks, about these things. It's been steadily increasing. It's great. And also, these guys coming from the door, frameworks like Agonis and Orleans, I'm kind of trying to solve it and are becoming, people are talking about this. Of course, these tools, I don't think they will ever magically fix everything, but they are a great conversation starter. And I think everyone would benefit of having a game server that could actually live on a cluster as if it was any other pod. Well, that's more or less it for me. I would like to say thank you. If you want to connect with me, there are some links. Please do so and have a chat with me in the event, and I hope to see you all at the after party. Thank you.
Thank you, Juho. Are there any questions?
Yeah, great talk. One question, what's the time used for running the game server, that is the little nightmare in the pod that you have? I know that some games are, let's say, 20 minutes maximum.
So you mean how long is a player state active on a server? Well, yes, quite a short one, because this is a mobile game. One of the gaming magazines rated our game as the top game to play on when you're going to the toilet. So you can imagine that's our play session. So it's not very long. So we could definitely do these things in the SDK where we say like, okay, we keep on spawning game servers all the time, and then say that it's going to be live for 1 hour and we only accept connections, then coordinate it and kill it. This is something we can do, but it requires a lot of changes to the SDK, and it's something that is like on the works.
Because I'm asking because you said that you have a problem with the game servers. We had the similar problem with the machine learning models that we spawn, and imagine we spawn pod for 1 hour.
Yes.
So GG.
Yes.
Thank you very much.
Exactly. Thank you.
Any more questions?
Yeah, thank you for the great talk. Just some internal details. So I assume you're not using like vanilla pods, so it's something like you're using some virtualization, probably Linux virtualization under the hood. So it's like kata containers, maybe, or
no. So we are using very vanilla pods. Yes, we're using a stateful set to spawn these out, and we run on top of EKS on AWS EC2. So
it's basically containerized something like that boils down to something that lives as an image in your internal registry.
Yes, the backend server is a .NET binary.
Okay, cool. Thank you.
Any more questions?
No Windows. That's a bad word.
Hello, how your deployment looks like? What about the downtime and maintenance windows, maybe?
Right. So yes, deployment looks little something like you put the game into maintenance mode and wait for the players to evacuate, and then you can do your thing. Of course, it requires usually we have a client build that goes also tied with the backend, and then you start doing a lot of GitHub actions and things like this to roll out the server. But yes, we will push out the new version of the image, essentially the stateful set. The pod itself is not stateful. It's just its memory is the stateful one. So pods can rotate. It's just losing the players if it rotates. We have database, of course, in the background holding the player play data, but the play session is the problem for us.
Any more questions? If not, then again, thank you, Juho.
Thank you.
I really understand your struggle because I was actually part of infrastructure team in gaming industry also, so I was dealing with the same issues. So that was really, really nice to hear your insight into this. Thank you.
Thank you so much, everyone.
Now it's time for dinner. So we will see here back in 1 hour.